This is the test for reducing sugars using Benedict's reagent. There are two types of Benedict's reagent. One is quantitative, which gives you an idea of exactly how much reducing sugar is in there, and another one which is qualitative, which is the one we're using today. It basically tells you, is the reducing sugar there or not? However, this Benedict's reagent is actually considered to be a semi-quantitative test because it doesn't just change from one colour to another colour. There are lots of intermediate colours it turns as well, and they will give you an indication of the concentration of reducing sugar within. Remember, a reducing sugar is any monosaccharide. Monosaccharides are monomers. They are carbohydrates and they include things like glucose, fructose, galactose. Benedict's reagent is highly sensitive. It will detect the smallest concentrations of a reducing sugar. For that reason, I have made a 0.01 molar solution of glucose. From that, I have made a dilution series of 20, 40, 60, 80 and 100%. So if glucose has a molecular mass of 180 grams and I want to make a 0.01 molar solution, how many grams of glucose will I add to my 1 decimeter cubed of water? I'll give you the answer at the end. Now in just 4 minutes you can see that the brick red precipitate is starting to develop. You can see that those test tubes actually need shaking to mix the reagent properly with the rest of the solution. Benedict's reagent actually contains copper sulfate, hence its blue colour. When it's heated with the reducing sugar reduces the copper sulfate and changes it to copper oxide, and that is what's left behind. Copper sulfate is soluble, and that's where the blue clear solution comes from, and copper oxide is insoluble, and that's where we get the precipitate from. So earlier we said if the molecular mass of glucose was 180 grams and we wanted to make a 0.01 molar solution, how much would you weigh and add to your 1 decimeter cubed of water? And the answer, of course, is 180 divided by 100, because 0.01 molar is 100th of 180. And here we can see our gradation of colour, with the darker browner reds being for the more concentrated and the bluey greens being for the less concentrated monosaccharide. Remembering that the colour gives us some indication of the concentration of reducing sugar within.